right. Well, thank you everyone for joining us today for our April 2023 DataBytes session. Today we're going to be learning more about our RioPACT tool, our new predictive analytics solution that helps us to measure the likelihood of a student's ability to persist into their next semester of enrollment with the college. Hopefully you all got a chance to attend the all-employee meeting a couple of weeks ago where we talked more broadly about the tool and kind of the longer term development process and how we got from partnering with some external vendors in the past to making the decision to develop that tool for ourselves internally, and some of the ups and downs of that process along the way. Today, what we want to share is a little bit more about the actual data model itself and kind of peel back the curtain a bit on how we were able to develop this data model internally. That was one of the limitations that we had experienced in working with some external vendors previously, is that due to the dynamic nature of how Rio conducts its operations and having our 40+ start dates per year and students in and out of courses and programs, we never really got the sense that the data models were fitting our students' behaviors very well. And so using an internally developed approach gives us more freedom and more control over the data, and leveraging the variables that we know are helping to influence the behaviors that we're wanting to see. So in just a minute, I'm going to turn it over to Dr. Fermin Ornelas, who has really spearheaded a lot of the development around this work, so that he can share with you more about his development process. And then we will hopefully have some time left over at the end for questions and any feedback that you might hope to provide to us. At this point in our process, we've piloted this tool with a couple of teams and trying to get it into the hands of users who are working with students on a daily basis. We think that that's going to be the most powerful application for this type of information, so that teams can prioritize their work and really focus in on students who need that additional support and that additional touch from the college. And so we'd love to hear from you all, just any thoughts and ideas you have on how we might continue to unbundle this work and share it more broadly around the college and engage with other teams and stakeholders to try and put this information into use. So I'm going to share my screen and I'm going to hand over the floor to Fermin. Take it away, Fermin.
I have to mute myself first, right? Well, the whole process, like Zach said, it began a while ago when we started talking to Civitas and seeing what they were doing. And from there on, we decided that the best approach would be to pursue our own modeling effort, right? And there was a difficulties in terms of understanding what they actually did. And they, for their own business model, they didn't want to explain what was going on. So I'm going to give you an overview of where things are right now and introduce you to some screenshots of some app that eventually advisors could use to when interacting with the students. Can we go to the next, Zach?
Just a second before I keep going. Thank you, Fermin. Are you all seeing the screen with the full slide deck, or are you seeing the presentation screen? I'm sorry. I didn't catch that.
Oh, one slide presentation one.
My slide just says predicting persistence at Rio Salado College in overview. And that's
Perfect.
the only thing I see.
Much appreciated.
Okay, so yeah, so for this particular effort, we basically took some data, right, from the fall of 21 and seeing whether the students persisted in the spring 22, right? So the problem that we have, as we know it, is that a lot of our students are not seeking an associate degree or a certificate, but rather they either are looking at the job market, specific skills for the job market, or maybe they are taking courses to transfer to ASU or the major university, right? So the persistency that we have in this particular sample is 53%, and the 47% are students that are not persistent, right? I tried several models, right? And out of all the models that I'll try, and we'll see as the discussion goes along, I selected something that is called gradient boosting machine, right? This is a sort of, it's an evolution of a decision tree modeling, right? Where the model improves by using some of the data from the samples that don't have a good prediction, right? And then I'll introduce you to the application that at some point it will display it in a browser. Can we go to the next slide? All right. So out of 19,459 records, right? The way this methodology works is I separated 80% of the data to do model development, and then the other 20% is used for validation. In other words, all the modeling effort and data analysis and data exploration goes into this 80%. And then once the model is ready, the other 20% actually, the purpose of it is to determine whether the model is doing a good job on the data or not, right? I might add that both samples have the outcome of interest. And in this case would be whether the student persisted in the spring or not, right? But in the 20%, we pretend that we don't know that outcome. So by doing this pretending trick, then we can compare how well the model actually predicted, right? Because then you know that the event is out there, and then you pretend as if the model doesn't know the final outcome, and based on that, it will score the students, and then the results are compared against the actual outcome. Right? I'll also show you a visualization of a correlation matrix among the features, right? To show whether there is a relationship among the variables. And this is part of something called exploratory data analysis. We also compare credits attempted, credits earned, and term GPA between persistent and non-persistent students. Can we go to the next slide? Right. So here you have a correlation matrix. If you look at the varieties on your I guess it's far right, then you will see that the var is between -1 and 1. So the closer the color it is to either extreme, then the more correlated the variable is with respect to the others. For example, if you look at the full-time flag, that's reddish, that's a high correlation, right? If you look at the other one, I think that's 69, right? If you look at the other one up there, cumulative, what is it? I can't see pretty well on this, right? But cumulative quality hours, that's highly correlated with cumulative, I think it's earned hour, cumulative attempted hours, right? So it's telling you that there is a strong correlation. The blue ones will tell you that there is a strong, but it's negative correlation. What's a positive correlation is when one variable goes up, the other variable also goes up. When it's negative correlation, when one variable goes up, the other variable goes down. Can we go to the next slide? Now, here what we are presenting is basically what is called a means test. And this is a test where we basically compare credits earned, credits attempted, and 10 GPA for persistent and non-persistent students. I kept the other variables only for consistency, right? If you notice, for example, cumulative earned hours, the non-persisters have a higher number of cumulative earned hours, mean of earned hours. What does that mean? It probably means that even though the students are not persistent for the next term, they might come back and take additional classes at some other point in time, and therefore they will continue accumulating earned hours, right? For the rest, in all the instances, the persisters have a higher mean. Now, I did a significance test, and all of them are highly significant at 5%. So that is telling us that there are differences between persisters and non-persisters. And having some sort of intervention for non-persisters could be an attempt to bridge the gap between the means and bring them closer, and maybe eventually where there are no difference between persisters and non-persisters, right? Can we go to the next slide? Now, we ran all the models, right? I ran logistic regression, gradient boosting, XGBoost, AdaBoost, and random forest. And why am I using this? You might ask yourself, specialists, why do we need all of these, right? Because in theory, these models are efficient in terms of predicting the outcome of interest. These models, especially the last 4, are considered models that don't have a distribution assumption, sort of something that is called non-parametric methods, right? So in other words, you just do the estimation, they will find non-linearities in the data and do the sample splitting until they come to a prediction, right? If you look in here, all the models are just on their metrics: accuracy, recall, precision, and F1 score. If you look at the bars, the gradient booster tune, which is the blue bar, it's almost at 80%. That one is followed by the random forest model, right? Which is almost at 80%, except that it does pretty low in accuracy, right? That is telling me, in the graph, that maybe the gradient boosted machine is the good model to predict persistency. I'll show you the table in the next slide, and you will see that its metrics are actually higher. Can we go to the next slide? All right. So here I'll give you, there is a table, and you can look at accuracy. Gradient booster got 79, random forest got 78, recall it got 80, random forest got 79, precision for gradient boosting it's 80, for random forest it's almost 80, the F1 score is 80, and the random forest it's almost 40, but not quite. So the models are kind of similar. However, we decided, that I decided that the gradient boosting machine was a better model than the rest. I also had to take a pause for water. I'm sorry, you can't see me, so. In the comparison, in the next chart, I'll show you 3 models, right? Random forest, gradient boosting, and logistic regression. And why did I keep logistic regression? Because logistic regression does relatively well in the previous chart, but it doesn't do as good as the other 2. However, a logistic regression, it's easier to implement and it's easier to interpret, right? So, and that's the reason that I kept the 3 models for comparison. In fact, one of the versions that we have in production is actually a logistic regression, right? And this other one, the gradient boosting machine, a version of it is also running in production. Can we go to the next Zach? Right now, here, after I selected the model, let me see. Okay. After I selected, these are the feature of importances that come into, of the variables coming into the model, right? Not surprisingly, term GPA, it's the most important variable in explaining persistency. That is followed by cumulative quality hours, by credits attempted, and cumulative earned hours. After that, we get a H22 flag. We also have a RioPACT flag. We have some college, but no degree, no college, full-time flag, not indicated, which means these are people that for some reason in the field of previous education, they did not indicate whether they had some college or not. And then at the very end, that some college, but in high school. So if we wanted to say something about the model, we could say that the top 3 are term GPA, cumulative quality hours, and credits attempted, right? So those are the top 3 that come into the model. Now I'm going to show you how the model actually scores the unseen sample, which is the test data set, in the next slide. Let's go to the next slide, please. Okay, so here is a confusion matrix. Then you would ask, well, why do we need a confusion matrix? What is a confusion matrix, right? A confusion matrix, basically, it will give you how well the model is doing out of sample prediction. So like if you look at your left-hand side, you will see true label, predicted label, right? So when true label is equal to predicted label, 0, 0, that means that's a true negative. It means the model went and identified the individuals that actually did not persist, and it did it correctly. Now, the other one, 1, 1, right? True label is 1, predicted label is 1. So the 1662 that are in that cell are the students that the model identified as persisters and were actually persisting. Then we have the off-diagonal elements, right? Since the model is tuned, the model was actually, for practical purposes, was forced to get a more rational number or a lower number for the off-diagonal elements. If you look at the upper right-hand side corner, that will be a false positive. And why is a false positive? Because if you look across on the true label, it will say an individual did not persist. If you look at from the bottom up in a 90-degree angle, then it will say, oh, the individual is predicted to persist. And that's what we mean when we say false positives. By the same analogy, right, when the true label is 1, but the predicted label is 0, then it means in that cell, those are false negatives. And why? Because they actually persisted, and the model identified those students as non-persistent, right? And this is the issue. Whenever one builds a model, right, what we would like to do is minimize the off-diagonal elements. The more they align along the diagonal element, then the better the model is, right? Now, if you look at the other graph on the side, right, that's an area under the curve. That's for the validation data set. And that's showing you three models, right? Again, the GVM, the random forest, and the logistic regression. Graphically, both of them perform very similar. But again, there is a slight advantage of the gradient boosting machine. And the logistic, even though it's not performing as good as it could, or compared to the other ones, but still is decent enough. And if we ever come to a situation where we say, okay, we can't implement this model, for example, for some reason, like it requires too much memory or it takes too long to come up to the results, then the logistic regression could be something that can easily be implemented. And that's the reason that I kept the three models for comparison, right? If you look at the value for the curve, that's one is 85, the other one is 86, and the other one is 80. So that tells you the higher the number is to 1, the better the model is at predicting. And incidentally, if that number goes up, then this graph will align itself to the upper left-hand corner, right? It'd be ideally, if it were just 100%, it almost will be like a 90-degree angle. So a model that doesn't perform well, on the contrary, then both lines will basically narrow themselves to the point where the 45-degree angle, which is the red line, will end up maybe touching the other curves, which would suggest the model is a poor fit for the data. Can we go to the next slide? Now, in this particular slide, we're showing how the model actually does the scoring, right? We know what the outcome is. So the outcome will be the actual, the predicted is what the model did. And basically this is because a probability, if you look at here, a probability, right? You will have values that are between 0 and 1, right? As a general rule, above 0.5, the outcome it's positive. Below 0.5, the outcome is negative. So when you look in here, then the probability gets transformed into a numerical value, and then through basically rules in the Python code, then they get assigned whether it's true positive, false negative, true positive, or true negative. And then we also color code those values. I mean, the persistency value or probability value based on the suggestions that Dave Hall did a while ago. So when you look at this, for example, at the first observation, right, it's actual is 1, predicted is 1. Probability is 0.86, and what is it? It's a true positive. Why it's a true positive? Because the actual is 1, and the model predicted it will be 1. So the persistence category, it's very high. If we look at the next one, the actual is 1, and the predicted is 0. Probability is 0.17, 0.18, right? So that's a false negative. And the persistent category is pretty low. And this is what I mean when the model misclassifies, right? That sometimes the both outcomes don't match. And this is a good example. They are not matched because the actual data is saying the student persisted, and the model is saying, no, the student did not persist, right? And then we go and look at observation number 3. Actually 0, predicted is 0, probability is 0.27. So that's truly a negative. The model has identified that the student was not persistent, and it truly was not persistent in the data. So that's a true negative. So that's pretty much in a nutshell. That's, let's say, like if the way we have it right now, there is a dashboard table, and that table contains this information. So that information, if an advisor, if a report is provided to an advisor, that's an interpretation that can be made on the data, and decisions can be made upon of it. Can we go to the next slide? Now, what I'm going to show you now is some other stuff that I've been playing more than for a while by now. Not a lot, but I've been playing, and the whole idea is to demystify, right? Because when we had Civitas, we never really knew, and I remember having those advisors asking them, why is that variable? How did they get, how did you get those results? And then the guy will pull tons of variables and say, oh, it comes from there. But we could never tell, right? So hopefully the three screenshots that I'm going to show you, it will give you an idea where we want to go, because the whole purpose is to get closer to what Civitas had, at the same time meeting the needs of advisors, which at the end will be the ones that will talk to a student, and those are the ones that need the information to give better advice to them, right? So I have three screenshots. The first one displays the model results. The second one displays the frequency distributions for proxy grades and persistency scores based on the categories that we selected, which happen to be also Civitas, very low, low, high, and very high, and medium, before I forget medium, right? And the third screenshot will actually allow the advisor to enter the values, and the model right there on the fly will score the student. It will say whether the student persisted or not, right? So without further ado, we're going to jump to the next one, right? So this is the screenshot. This is the actual data. And this is the persistent category, color coded. Here, if I were to click on for example, on the pros for RioPACT, then it will bring everything in here. If we were to click down there where it says display data size, display columns, then you can get additional information on the data. There are more options underneath here, but I couldn't fit everything on the screenshot. But that's where the whole idea is going. And then here we have three models. Right now, I'm showing you RioPACT predictions, but there is another model, which is the GVM online predictions, and there will be right underneath another retention model coming into the pipe. Can we go to the next slide? And these are the metrics. It's still work in progress, and it's open to suggestions. But right now, it's just what I wanted to show you is where we are going with this idea, right? In the browser, if I were to show you in the browser, when you click in one of the bars, because this is, it's interactive, it will show you the total, the percentage, and things like that. And you go to the other one, it will show you also the statistics for each one of the bars. Now, when you go and click underneath, then you have the categories: very low, low, medium, high, and pretty high. Like here, I selected low. Well, it gave me 724. And right below underneath, there is an option to download the data set. Like if an advisor says, okay, I want to look at those 724, then she could download the data as a Excel file or CSV file and look at the actual data. If we were to select another one, high or pretty high, then it will happen the same thing. It will allow it to download the data. Can we go to the next slide? Now, this is the third screen. It's a variation of the other one, right? But here, the advisor is allowed to enter the values for a particular student, right? Just can enter the cumulative GPA, can enter site engagement, can enter days since login, assignment dues, the first time in college indicator, and the mean P ratio, it's a proxy of how the student is doing. This is not part of the model, but I kept it because with that, it's an additional information that the advisor can use when talking to the student. Now, once he goes and click into that red dot, then the model will say, well, the student is persisting or the student is not persisting. In this case, since site engagement was pretty low, the model says the student is not persistent. And then right here, right below, there is also the persistent category. So it will give the metrics overall, how many and what's the mean is and things like that, right? If he or she were to click on online prediction, then it will get another screen like this, and all the variables for that.
Hey, Fermin, I don't know if you can hear me over your computer, but I can hear you in our office, but your audio is dropped off of your computer. Can you check and make sure you didn't accidentally mute yourself?
No, it's not.
Oh,
No, it's
there
not
you go.
muted.
You're back.
It's not muted. I'm wondering if the icon, if the arrow, I just moved
Nope.
the arrow to the.
You're back online now. Thank you.
Okay. Anyway, it depends on how far you guys miss me in the conversation, but all I was saying is this is a screenshot, and these are the variables that are in the model. All the advisor would have to do if he or she wants to get a good feeling for what is the model doing behind the curtain, it's enter the values, and then the model will tell her or tell him if the student is persisting or not. Right? If he or she were to click on the next option, then another screenshot would come with another set of variables for that particular model. Once we develop the retention model, then it will also show another screen for that particular model, and it will score for that model, for the retention model, it will score, the student will have a probability whether he will persist a year from now. This is 6 months from now, or from this term to the next. The other one will predict persistency from one fall to the next fall. I hope you guys didn't miss much.
No,
To the next?
everything came through for the most part. There was just a couple sentences that got dropped.
Okay. So what is the conclusion and the direction that we're going, right? Like I said, I mean, we pull fall 21 and spring 22 to develop a persistency model, right? Persistency model, right? Models were comparing their respective metrics, and the gradient boosting machine was the model of choice, right? Term GPA was the most important predictor. The means test indicate the term GPA, grades attempted and earned, suggests that more attention should be provided to students that have lower values in those variables, right? Again, we go back to some degree to RioPACT. If we can manage to make them do well in their courses, that eventually could result in a higher persistency, right? The classifier, right? I presented you the simulation results just to give you an idea on how the model actually goes in identifying the different segments for prediction, right? very high, high, medium, low, and pretty low, right? And they were color-coded based on David Hall's suggestions. Can we go to the next slide? Right. So I provided the screenshots, and this is open to suggestions. More like, the whole idea is to get people a little bit excited, and maybe they'll say, yeah, this looks all right, or no, because it's still, I mean, if you compare this to some of the apps that are out there, because there are many apps out there, right? And some of them claim they do things marvelous, and maybe they do. But if we take baby steps, I think we'll do fine, and eventually we'll come to a point where we'll feel comfortable with using these things, right? This is where we are going. I mean, you have heard of ChatGPT, artificial intelligence, and this is the field. This field is called machine learning modeling applied to learning analytics. So that's what we're doing. And my idea as we go forward is to allow for more options, to allow for more filters, right? But for the time being, these filters allow me to show you what it could be possible, what is possible. I have actually an application, not this one, because we still have to deal with security issues in terms of accessing the data and who can access it and all that stuff. But I am running an app in Heroku. Heroku is an application from Salesforce. So that application, I developed the application, uploaded into GitHub, and then Heroku goes to GitHub and borrows all the info and then displays it at his website for $5 a month. So once we get ready, that's what I would like to do. And at that point, then we can tell people, yeah, we can show it to you to see how it works. And then, of course, once it's out there, then if you have a mobile phone, you can log into mobile phone, you can look at the results, right? So that's where we're going. And I mean, I feel comfortable about it. I think we are right there where everybody's trying to go, and should be able to do it. And, there are technical difficulties that arise because of the techniques that we're using are a little bit complicated, but not impossible to do it. So, like I said, I mean, versions of these things are already in the server. The problem is to display stuff in the server is more complicated. And I think everybody is browse oriented these days, So this thing runs in the browser. If I tell you more, I have Jupyter notebooks that are running all this stuff, and Jupyter notebooks runs in the browser. I have another version that runs in the server, right? The server is not as flexible. Jupyter notebooks is flexible because it runs in Anaconda. So with that saying, I'm just going to quit. And if you have any questions or suggestions, put them in the chat or send it to us at any point in time.
Well, thank you for sharing all of that hard work Fermin. And so now I hope everybody is ready for the pop quiz about Fermin's presentation.
Yes.
You'll have to tell us what all of those terms were in your own words, of course, without using ChatGPT. In all seriousness, Fermin's work is incredible. This isn't being done in many institutions internally, and especially in community colleges. As we've talked about, as Fermin talked about, we tried using other vendors, we tried looking at other applications that were out there, and none of them were really attuned to the needs of our students. On top of the fact that as a community college with open access admissions, we've got such a diverse array of students that we serve. We know Rio students are even more nuanced than even Mesa Community College as an example. And so we need to build these things internally for ourselves so that we understand the metrics that are being, or excuse me, the variables that are being considered in the methodology, and that we can, open up, the hood, get under the hood and work on the engine, so to speak, and be able to have full control over the model and the types of data that it's bringing in for consideration. And so just kudos to Fermin and to all of those who helped on the Civitas work prior to this and the transition point between working with that vendor and developing this model for ourselves that helped to inform this work. What Fermin showed you today was just a brief glimpse into a very long development process where we looked at different variables and had conversations with different subject matter experts around the college to learn more about how this information could be useful to their teams and what types of things we should be considering when building. And hopefully, as we continue to refine, because it's something that's never going to be done, quote unquote, there will always be tinkering that can be done. As we continue to refine and work on that, we'll continue to strengthen the model and be able to help support our students that much more. I also just wanted to make sure I gave a quick shout out before I forgot to Trung on our team for helping to project manage the implementation of some of the pilot that we've done in getting teams around the college to work with this data. And then also Christina and Mary in DRS, as well as David Hall and his team in advising for partnering with us to explore putting this data to use. As you saw in the last few slides of Fermin's presentation, we want to make this information more user friendly. So we're color coding the prediction scores and ranking them into different quintiles so that as an end user, you're just seeing the English language representation of all of the stats that are on the background that help to predict the student's likelihood of success. And so, we're going to continue to work on how we're going to refine the interactivity of some of that information, building out some of those custom applications like Fermin was showing, and trying to integrate the data into the plethora of systems that the college has available. So all future work to come, but what we're hoping to get from folks, if there's any feedback or questions, it would be great to just use the time that we've got remaining, if there's any appetite to have a conversation about your initial reactions, how you think this might be useful, any suggestions that you might have for us in terms of other things that we might consider or other teams that we might engage in trying to continue to expand the use of this. And so we'll turn it over. We got about 10 minutes or so left and see if there's any questions or feedback that anyone has.
I'm thinking that at some point in the near future, we may be able to do something so that advisors can use like some kind of a pilot, have the little app and as a pilot just to give them a sense of how things work.
Yeah,
Mm.
and in that application, I'll keep talking if no one else is going to chime in. That application, I think, is really where the secret sauce of some of this is going to come from. It's not just having the model running in the background that's going to make this thing work. It's going to be people actually interacting with the data and using it in their day-to-day. Some of the ways that we've already tried doing that is inserting the data directly into different reports the teams are already using that can just help to visually identify students that might be off pace, so to speak. That way, in all of the contact activity that teams are doing on a daily basis, if they can use that information to help prioritize specific students who might be at most need, then we want to be able to do that. But in addition to that, we want to provide tools like the application that Fermin was showing the screenshots of to be able to explore the data further. So if, for instance, you're on the phone with the student and you can plug some of their variables into the model to see, how we might be able to influence the student's behavior to get to a place of more success. So that could be a suggestion like helping a student to make sure that they're logging into the LMS on a more regular basis and engaging in their course content. It could be referring them over to different services that are available to them within the college to make sure that they've got access to tutoring or counseling or whatever the case may be. And so those are all things that we want to continue to explore how we can make the data more experiential so that folks not only have the reporting, but then the ability to go in and do some additional investigation on their own. So Michelle asked a couple, or there's a question about persistence in previous college education. So, okay, I see that you already grabbed that for me.
Yeah, just, we try to capture that behavior, that creating variables out of previous education. Yeah.
Yeah, and so I think right now we've got a good sweet spot on the variables that are taken into consideration where there are some academic performance metrics, credits attempted and earned, GPA, things like that. And then there are also a few selected student demographic characteristics that are brought into consideration as well. Things that we, in the exploration process, were determined to be good, strong predictors of persistence, but also helps us to attune the model to the diversity of the student body of the college and making sure that we're taking some of those characteristics into consideration if they are seen to be strong predictors of success. Agreed. It's a lot of information to take in. We're very fortunate to have Fermin at our disposal. There's really no one else in the district currently that's engaging in this level of work. So we're fortunate to have Fermin on our team and here at the college and helping to engage in this work and push us forward as an institution in this space. We can absolutely share the slides, Michelle.
And the whole effort was just, it's basically trying to get everybody more comfortable with all of this stuff, because the stuff is coming left and right every day. Like when we're listening at the other person, I mean, the one that, what was it? Edu Next or something. I forgot the name, right?
Mm-hmm.
Just when says, here it is. And then there is the other one that Zach mentioned, that, what is it, tutor selector or something, was dropout detector or something. There's a lot of stuff. And if you go out there, I don't know, it's just that let's say if you join the users group for Tableau, oh, there is tons of people that are doing other things. And so we need to be, mainstream. And that's the whole purpose of this, that will allow us to enter a little bit skeptical and a little bit skittish, but eventually we'll get sure-footed and we'll be able to, to have something that is relevant and is useful, and that should address the needs for better attention to students. And thank you for listening.
Yeah, thank you indeed. And Aaron brought up a good point in the chat around whether or not this data is being presented to students. And right now, that's not happening. If you go looking out there, there's a lot of information about the pros and cons of that type of application of the information, and a lot around the ethical considerations of, for instance, telling a student, hey, our, machine learning model is saying that you're not going to pass. And, some of the unintended consequences that might result from something like that, an interaction like that, and creating kind of a self-fulfilling prophecy for that student that, the chat GBT bot is telling me that I'm going to drop out. And so I might as well give up now. So, we want to make sure that we're taking those things into consideration and not going too far too fast. Ultimately, I think it would be great to explore ways in which we might introduce some version of this type of information to students. We already do it in some instances with RioPACE. So they're, seeing for some students those icons in RioLearn and getting that benchmark to see, am I on track or am I falling behind? But I think this tool, kind of takes that to another degree. It is something we want to be careful with in terms of how we might represent that information to students. So that'll be certainly on the in the area of future considerations for this work, and starting to explore maybe what others have done in this space related to sharing that content with students. Well, with that, I guess I'll kind of call us to a close. I appreciate everybody coming today. As always, we'll get the recording from today's session put up onto our IR YouTube channel and shared out along with the slides so that other folks can review the materials and hopefully learn more about the development process of this tool. Just again, thank you to everyone who's been involved in the development of this work. Whether directly through a pilot program or indirectly through consulting in some of this space with us along the way. We appreciate all of your contributions and your partnership. And hopefully we can work together in the future to continue to advance the rollout of this tool and hope to make our students more successful. So thank you all so much. Enjoy 4 extra minutes back in your schedule. Hope everyone gets a chance to grab a bite to eat, and hope you all have a great rest of your Wednesday. Thank you so much.
Good job.